Hello everyone! For today's lesson, we will be discussing illustration of quadratic equations. Here is the objective. At the end of this video, you should be able to illustrate quadratic equation. Before we proceed to our main lesson, let's first have a review. So the title of our activity is, do you remember these products? Find the product. For number 1, 3 multiplied by the quantity of x squared plus 7. The answer is 3x squared plus 21. Very good. Just apply the derivative property. 3 times x squared is 3x squared and 3 times 7 is 21. So the answer is 3x squared plus 21. Next, number 2. The quantity of w plus 7 multiplied by the quantity of w plus 3. The answer is w squared plus 10w plus 21. Okay, correct. Just use the FOIL method. In this case, the first terms are w and w. So w multiplied by w is w squared. W times 3 is 3w. 7 times w is 7w. And the last term, 7 times 3 is 21. Combine like terms, 3w plus 7w will give us 10w. Next, number 3. 2s times the quantity of s minus 4. The answer is 2s squared minus 8s. You need to apply again the distributive property. Next, number 4. Find the product of the square of 3 minus 4m. The answer is 9 minus 24m plus 16m squared. In this case, just apply the square of binomial. Expanding a square of binomial. Just square the first term. So 3 times 3 will gives us 9. Multiply the two terms, 3 and negative 4m. The result is negative 12m. And then, double the result. So, the answer is negative 24m. And square the last term. So, negative 4m, the square of this is positive 16m squared. And last number, the quantity of 8 minus 3x times the quantity of 8 plus 3x. This is the sum and difference of a binomial. The answer is 64 minus 9x squared. So the shortcut for this is multiply the first terms, 8 times 8, 64, and multiply the last terms. Negative 3x times positive 3x is negative 9x squared. Now, what common characteristics do these polynomials have? So, these are the answers in our activity earlier. 3x squared plus 21, w squared plus 10w plus 21, 2s squared minus 8s, 9 minus 24m plus 16m squared, and 64 minus 9x squared. Okay, correct. These polynomials have one variable, and the highest exponent of the variable is 2. Quadratic equation is an equation which is in the second degree. It takes the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. Ax squared here is the quadratic term. Again, ax squared is the quadratic term. Bx is the linear term. Bx is the linear term. And c is the constant term. C is the constant term. So, ax squared plus bx plus c is equal to 0 is the standard form of a quadratic equation. Why is that a must not be equal to 0? Once a is equal to 0, the quadratic term will be 0x squared. And 0x squared is already 0. So, the remaining terms are bx plus c and then equals 0. This time, our equation is not in the second degree. So, therefore, it is not a quadratic equation. It is a linear equation. So, always remember that a must not be equal to 0. Incomplete forms of quadratic equation. First, ax squared plus c is equal to 0, meaning there is no linear term since b is equal to 0. Second, ax squared plus bx equals 0. This time, the constant term is equal to 0. And number 3, ax squared is equal to 0. B and c is equal to 0, meaning there is no linear term and constant term. But it is a quadratic equation. Degree of an equation is determined through the highest exponent of the variable in an equation. In this case, in a quadratic equation, the degree must be 2. So here are some examples of quadratic equation and not quadratic equation. X squared minus 5x equals 8. So we have one variable involved and the degree is 2. Though it is not written in standard form, it's still a quadratic equation. Number 2, 11 equals 3x squared. So this is an example of incomplete quadratic equation. There is no linear term and it's not written in standard form. Last, 2x minus 4 quantity squared equals negative 5x. By applying the concept of square of binomial, we could get a degree of 2. And these are the examples of not quadratic equations. 3x minus 7 equals 6. It is not quadratic equation because, correct, the highest exponent of the variable here is 1. Next, 5x multiplied by the quantity of x squared minus 8 equals negative 2x. It is not quadratic equation because when we apply the distributive property, 5x times x squared is 5x cubed. So, the degree is 3. 6x minus 3x squared plus 1 equals negative 3x squared. When we combine like terms, negative 3x squared, transpose this, positive 3x squared, it will become 0. And once a becomes 0, it is not a quadratic equation. Now, let's proceed to the next part. Steps in writing quadratic equations in standard form. Again, the standard form is ax squared plus bx plus c equals 0. Step number 1. Find the product applying the mathematical concepts on special products. So this is the activity number 1 that we did a while ago. Step 2. Transform into the form ax squared plus bx plus c is equal to 0, applying the transposition rule. Example number 1. Write the quadratic equation 3x squared minus 8x equals 4 in standard form ax squared plus bx plus c equals 0. Then find the values of a, b, and c. So the given is 3x squared minus 8x equals 4. So it is not written in factored form, so we don't need to multiply them. Transpose the constant term. So in this example, the constant term is 4. When we transpose this, positive 4 will become negative 4. So the equation will be 3x squared minus 8x minus 4 equals 0. Make sure that the first term is a quadratic term followed by the linear term and the constant term, and it is equal to 0. If there is no linear term, it's okay. If there is no constant term, it's also okay. Next is to find the values of a, b, and c. Here, the value of a is 3. The value of b is negative 8. And the value of c is negative 4. Next, example number 2. Write the quadratic equation 5x multiplied by x minus 4 plus 2 is equal to 0. So that is the given. Next is, as you can see, we could apply the distributive property by multiplying 5x by the quantity of x minus 4. So 5x times x is 5x squared, and 5x times negative 4 is negative 20x. And then just copy plus 2 equals 0. So let's see if it's already in standard form. 5x squared, quadratic term, negative 20x, the linear term, and plus 2, the constant term. Now, the values of a, b, and c. A is equal to 5. B is equal to negative 20. And c is equal to 2. Next, example number 3. Write the quadratic equation 2x multiplied by the quantity of 3x minus 4 equals 11. That is the given. And then same with example number 2, we need to apply the distributive property. So the result is 6x squared minus 8x equals 11. Is this in standard form? No. We need to transpose the constant term, which is 11. So when we transpose positive 11, it will become correct, negative 11. So the equation will be 6x squared minus 8x minus 11 equals 0. Then find the values of a, b, and c. A is 6, b is negative 8, and C is negative 11. Next, example number 4. Write the quadratic equation. The quantity of x plus 3 squared is equal to 5x in standard form. So that is the given. In this case, we will be applying the square of binomials, expanding the square of binomial. Or we could use the FOIL method, just multiply x plus 3 by itself. So in this case, for us to expand square of binomial, square the first term, the answer is x squared. Multiply the two terms, x and 3, 3x, and then twice the answer is 6x. Square the last term will be 9. So we have x squared plus 6x plus 9 equals 5x. So we still have a term on the right side of the equation. So we need to transpose it. And 5x is the linear term. So it will become x squared plus 6x plus 9 minus 5x equals 0. And we still need to combine like terms. So 6x minus 5x. The linear term will be x, correct? So we have x squared plus x plus 9 equals 0. The values of a, b, and c. A is equal to 1 if there is no number beside x squared. The numerical coefficient of x squared or the value of a is 1. B is 1 and C is 9. Next, example number 5. Write the quadratic equation. The quantity of 3x minus 1 squared is equal to 2x minus 7. So again, apply the FOIL method or expand square of binomial. So we have 9x squared minus 6x plus 1 is equal to 2x minus 7. Transpose 2x minus 7. 9x squared minus 6x plus 1 minus 2x plus 7. When we transpose 2x becomes negative 2x. When we transpose negative 7, it becomes positive 7. And then, we need to combine like terms. In this case, negative 6x minus 2x are similar terms. Aside from that, we also have positive 1 and positive 7. So, the result will be 9x squared minus 8x plus 8 equals 0. Values of a, b, and c. A is 9. B is negative 8. And C is positive 8. For the last example, write the quadratic equation 2x minus 5 multiplied by the quantity of 5x plus 3 equals x squared. We need to use the FOIL method. 2x times 5x is 10x squared. 2x times 3 is positive 6x. Negative 5 times 5x is negative 25x. Negative 5 times 3 is negative 15. And then copy equals negative x squared. Next is to transpose negative x squared. So 10x squared plus 6x minus 25x minus 15 plus x squared equals 0. And then, we need to combine like terms. So look for the similar terms. Okay, correct. We have 10x squared and positive x squared. We also have 6x minus 25x. So the result will be 11x squared minus 19x minus 15 equals 0. And the values of A, B, and C are: A is 11, B is negative 19, and C is negative 15. I want you to try this. Okay, identify each equation as quadratic or not quadratic. If it is a quadratic equation, write it in standard form. So I will give you 10 seconds to do this. For number 1, 3x minus 2 equals 0. The answer is not quadratic. Very good. Next, number 2. 2 multiply by the quantity of x plus 3 squared equals 0. If you're not yet done answering this question, you may pause this video. The answer is quadratic. And the standard form is, of course, we need to expand first the square of binomial. So 2 multiplied by x squared plus 6x plus 9 equals 0. And then distribute 2 to this trinomial. So the result will be 2x squared plus 12x plus 18 equals 0. Next, number 3. X plus 3 plus 8 equals 0. The answer is not quadratic. Number 4. X cubed minus 3 equals 0. The answer is not quadratic. Correct. And for the last item, number 5, x multiplied by the quantity of x plus 3 plus 5 equals 0. The answer is quadratic. And the standard form is x squared plus 3x plus 5 equals 0. So what property did you apply or did you use? Very good. The distributive property. X times x, x squared, and x times 3 is 3x. Just copy plus 5. For our generalization, quadratic equations are equations in the second degree. The standard form is ax squared plus bx plus c equals 0, where a, b, and c are any real numbers and a is not equal to 0. If you want to have more exercises about illustration of quadratic equations, you may answer this sit work. All you have to do is to get a pen and a paper and then answer this. You may take a screenshot of this part of the video or you may pause this video so you can have more time in answering the seat work. And then at the end of this video, look for the answer key and check if your answers are correct. I hope that you have learned how to illustrate quadratic equation. You did great!